fluid pressure, and this first film on fluid pressure is about the pressure principles. And as you see from this image in the corner, you see that the fluid pressure is what drives the water out of the bottle. And clearly the pressure is higher at the bottom compared to the top of the bottle. And the pressure is defined as force per unit area, and the force applied perpendicular to the surface of an object. Perpendicular vinkelrett in Norwegian. The SI unit for pressure is pascals, which is in tribute of Blaise Pascal, and it's 1 Newton per square meter. So these are the base SI units that this builds on. Other units for pressure, you have bar, which is 100 kilopascals, which is very closely related to the atmospheric pressure at sea level, which is 101 kilopascals. So the bar unit is very close to the atmospheric, and that's why you have the unit. Also, millimeter mercury comes from the pressure that 1 millimeter column of mercury gives to a surface, and that is popular for example, blood pressure meters, and also for atmospheric meters. The American unit PSI, pounds per square inch, which is very popular within the petroleum industry, since much of the idea of much of the engineering within petroleum business comes from the United States, where the PSI is the most common unit. As you see here, if you have a gas inside a container, the molecules of the gas produces pressure on the wall, and as they bounce off. So when this molecule here bounces off the wall there, it produces a force perpendicular to the surface. And that's why also, if you go page up, you see the water that jets out of this bottle jets out vertical compared to the wall of the bottle. If I were to tilt the bottle like this, the water would jet out in this direction and then gradually bend off like that. Also, the water doesn't yet jet out in that direction, for example. It comes out perpendicular to the surface. And also the pressure here is the same, doesn't matter in which direction I measure it. It's the same. The pressure is the same at a given level in the tank here. When we measure the pressure of a container, we can measure it in 3 different ways. First way to measure pressure is absolute pressure. That is when you compare the pressure that you have on your site, you compare it to vacuum. So this is a setup where I have an airtight space here where I have vacuum, and I and I expose that to a pressure, and the pressure will bend the lid here downwards, and the amount of bending depends on the pressure that we have. Differential pressure measures the pressure difference between 2 gases or 2 fluids, and if the P2 is higher than P1, then this lid here will bend upwards. But if P1 is larger than P2, the lid here will bend downwards, and that will give us the pressure difference between the two. Then we have a special case of differential pressure, which is gauge pressure. And gauge pressure is when you compare it to the atmosphere outside. For example, when I fill the tires of my car with air, the meter there presents the atmospheric pressure compared to the outside of the gas station or wherever I filled my tires. So here graphically presented, the absolute pressure is compared to the absolute vacuum, while the gauge pressure is the difference between the atmospheric pressure and the pressure that we want to measure, and the differential pressure is to compare two different pressures here. For example, if I have a pipe and in the pipe I have some kind of obstacle, I can measure the pressure here on one side and the pressure on the other side, or I could use a differential pressure meter which will measure the difference between the two. dP, differential pressure. When we measure the pressure of a system, in this case a differential pressure, what we really do is trying to measure the deformation of something. In this case, the lid of this setup. And so all we have to do is actually to measure the displacement of some sensing element. And in this, you can use, for example, strain gauges, like in the figure here. You can have direct reading, like here, where the force is directly converted to the angle of a pointer of an arrow. You can use, for example, LVDTs, or Hall elements, capacitive elements, piezoresistive elements, piezoelectric, optical, potentiometer, many different ways to detect it, but the thing is always detect the change of an object.